Welcome. We're going to look at solving systems of equations in three ways. First by graphing, then by substitution, then by elimination. The goal for each one of these is to get an answer where it's an x value and a y value. Because in every one of these cases, what's happening is you have a line and another line and a place where they meet, and that is the solution that we're looking for. If you're graphing it, you find the spot where they look visually, you can see where they meet. In substitution and elimination, you usually solve for one, like an x equals, and then you figure out what the y is based on that x. And then you put it into that form because it's a coordinate point. That's the coordinate point form. All right, let's take a look at the first one of these, solved by graphing. There are, of course, three different ways usually that you can graph a linear equation. One of them is using x-intercepts and y-intercepts. Another one of them is by doing a table of values, and another one of them is by changing it into slope-intercept form. I'm going to do a couple of these that way. I'm going to take this one and change it into slope-intercept form, 2x plus 4y equals 12. I'm going to subtract 2x from both sides. Let's see. Yep. That's 4y equals negative 2x plus 12. And then I'm going to divide everything by the 4. Thing to remember here is to divide every term by the 4, even the one at the end. So we get y equals negative 1/2 x plus 3. And I'm going to graph that point. And I'm going to go to 3. So that's using the y-intercept. And then I'm going to use the slope. I'm going to do negative 1/2. So it's a rise, but it's going down because of the negative. And it's a run, and the run is positive, so it'll still go the normal way. So it's down 1/2, down 1/2, down 1/2, down 1/2, down 1/2. I can also write it as 1/-2. So it'd be a rise going up, but then the run would be going the other direction. That means I can go up 1/2, up 1/2, up 1/2, up 1/2, and up 1/2. That makes it much easier with so many points to draw a straight line. Now we're going to draw the other one. And the other one I will do by using an XY table. Okay. So when I look at this, it's with 4s times 4s. I think I'm going to make my x's like -4, 0, and 4, because 4 is CDB, the order of the day in that one. So if the x is -4, minus 4y equals -24. So there's my x value put in. I'm going to add 4 to both sides. And I'm going to get -4y equals -20. When I divide by the -4, we get y equals -5. So all of this has to do with that one. Now I'm going to put a 0 in. If I do 0 minus 4y equals -24, well, 0 doesn't matter then, it goes away. And we have dividing by -4 on both sides. And we get that, well, let's see. These cancel out. 4 goes into 24 6 times. So the y is 6. Okay. Ooh, and I just realized I made a mistake. Let's come back here. Notice that here I put the negatives underneath it, and that enabled me to cancel them out. Up here I did not do that. And when I did not do that, I didn't remember that these two negatives would cancel out to make that a +5. there is a reason why it's worth it to put the number underneath and pretend you're dividing, or actually do dividing, because it's very easy to forget negatives. And I'm glad I thought of it and went back and fixed it. Making a mistake's not a problem. It's going back and fixing it in time that would be really important to do. And all of this one has to do with that. Now we'll do the last one of these because I really only need 3 good points to be able to graph something well. So let's put a 4 in for the x, 4, and we're using this one here now. Okay, so the same like we just did, minus 4y equals negative 24. Let's subtract the 4. So negative 4y, now it's negative 28, and when I divide by the negative 4, I am going to get a positive y, and I'm going to get 4 to 28 7 times, and it's a positive 7. So we have these coordinate points. The plus don't really need there if I'm careful about it and know it's not a negative. So now let's go ahead and graph those, and I'll use the blue here to graph this one. So I have each of these points that I'll do in blue. So negative 4, right there we see where it's probably going to meet. But let's go ahead and finish this anyway. I'm going to put all of these points in and draw that line. And it's pretty obvious now where the 2 lines meet. This point here is negative 4 and 5. That one actually does deserve like a red. Or maybe the black. For the actual point. And that's the solution, negative 4 and 5. That's the place where those 2 lines meet. Actually, I meant to put it down here, so let's do that. Now let's do another one. Oh, wait a minute, that's the graphing one. So what we've done here is we've just done a graphing reminder how to do it. You've seen it before. Now let's do it as a substitution. We're going to do the same problem. Notice this one here, these ones, we're going to do the same ones down here, which means we should get the same answer. Well, let's do it though through this method. The substitution method means taking an x or a y or what it stands for and putting it into the other problem. So this one is nicely set up to have an x here by itself. If we add 4y to both sides, x is equal to, well, we have a couple of choices. 4y can go in front or back. It really doesn't matter, but I think I'm going to put it in front, as long as that negative stays with the 24. Yep. Now that I've done that, we have these 2, and I can take this x and put it in here, which means this thing, because x is equal to that, 4y minus 24 can go in place of that x. So I'll arrow here, and instead of x, I'm going to put 4y minus 24. So that's the x there. Plus 4y equals 12. So now I look at this, one easy way here to help me would I divide everything by a 2 and simplify the problem. But that's not always true in some cases, because if this was over here as a 12, if this was like an 11 or something, we couldn't do that. So I'm going to do it the more classic way here. Let's distribute the 2 into both of these. Okay? And that's going to give us 8y minus 48 plus 4y is equal to 12. The 8y and the 4y, 8y plus 4y is 12y minus 48 equals 12. Let's add the 48. 12y equals 60. Divide by the 12 on both sides. I need to write that meter there. And we get that y is equal to 5. This is not enough, though. It's nice to know this, but we need to know the x value. So take either one of the original equations, right? Either one. It can be the first one or the second. I think the second one is actually going to be easier to work with, although it doesn't really matter. Minus 24 for that. So the second equation was x minus 4y equals negative 24. And I'm going to put that y equals 5 in there. That means I have x minus 4 times 5 equals negative 24. So that's x minus 20 equals negative 24. Let's add 20 to both sides, and x is equal to negative 4. So I have these two things, but the only correct answer is to put it together as a coordinate point, negative 4 and 5. So here we've graphed it. Here we have found it by substitution. Now let's do the elimination method. And for the elimination method, we're going to do the same problem, and then we're going to do a couple harder ones. And we're going to build up some of the more difficult types of problems. So on this one, remember that you can simply just plain add equations. So I can add 2x plus x and get 3x. 4y take away 4y, well, that's a 0, so I don't need to include it anymore. And 12 plus a negative 24 is a negative 12. Divide by the 3, x equals negative 4. And I can put that now into either one of these problems, such as 2, negative 4 plus 4y. So I'm going to take the first one here and bring it down, plus 4y equals 12. That's negative 8 plus 4y equals 12. I'm going to add 8. And so I get 4y equals 20. Divide by 4. No negatives here in this one. Equals 5. So we have negative 4 for the x and 5 for the y. What's interesting about this is it's simply a matter of one is plus and one is minus. So you simply just add up the two equations. You don't have to change anything. Sometimes you do have to change something. Let's take a look at the second one on this page. And what we see here is we cannot just simply add these. If I were to do that, and don't do this, I'm going to erase it in a moment. 6 plus 3 is 9x. 5 take away 1 is plus 4y. And negative 8 plus a negative 11 is negative 19. So now we have one equation, and we can't solve it because they both have has two variables in it. So we can't go anywhere here with this. So instead, let's erase all of this out. Instead, what we're going to do is notice that, oh, this is a positive 5. If only there was a 5 in this place, I could have plus 5 and minus 5. Huh? Well, guess what? We can do that. I am going to take this first one and I'm going to multiply everything, second one, I'm going to multiply both sides by 5. So the first equation stays the same. But the second equation changes. 5 times 3 makes that 15x. 5 times negative y is negative 5y. And 5 times negative 11 is negative 55. Now let's add them together. That's 21x. This is 0. And we get negative 63. Yes, negative 63. 55 and 8, and it's negative. And here at this point now, if we divide by 21, we get that x is equal to negative 3. If x is negative 3, we need to put it back into one of the problems. It doesn't matter which one. I'm going to take the first one this time. So it's 6 times negative 3, or x equals negative 3. 6 times negative 3 plus 5y equals negative 8. I get negative 18 plus 5y equals negative 8. So I'm going to add 18, and I get 5y equals positive 10. And when I divide by 5, I get y is equal to 2. So the actual answer for this is negative 3 for the x and 2 for the y. That's the place where these two lines meet. If I were to be drawing them, I don't know where these lines would go, but I know at negative 3 and positive 2, there's the point, which means one line could be going like this. Make it a little bit neater. And one line can be going like this. Or in some other way, the second one could be going like this. We don't know. Or it could be a horizontal or a vertical one. All we know is that this point, negative 3, 2, that is the place where these two lines meet. And if you draw them, or do the substitution here. Well, elimination is this one. Let's eliminate in the last one. In this case, what's happening, in each of these cases, what's happening is we're eliminating a variable. We eliminated the y by changing the equation. On this next one, I can't do the same thing. I cannot make the 8 into a 5. I can't make the 5 into a 2, or the 2 into a 5, or the 5 into an 8. I can't do any of those. But what I can do is change both of them. So what I'm going to do here is I'm going to change this one by something and that one by something. When I look at the numbers, it would be easier if I multiplied this one by 2 and this one by 5. If I did that, I'd get a 10y, and here I'd get a negative 10y, and then they'd be able to cancel. So let's rewrite them here. If I multiply, and I'm going to get those, but I'm going to multiply by the 2 and the 5. So the 2 on the top one makes it 16x plus 10y equals negative 110. Right. The bottom one, 5 times each of those gives me a 25x minus 10y is equal to negative 95. And now I can add them. So I'm going to add them, and it gives me 41x equals negative 205. And a calculator will tell you that if I divide both of them by the 41 in order to get the x by itself, 41 goes into 205 5 times, and it's a negative. So now that we've done that, we're going to take one of these problems. I'll take 8x plus 5y equals negative 15, and I'm going to plug that in place of x, and we'll figure out what y is. This gives us 8 times negative 5 plus 5y equals negative 55. So here we have a negative 40. Let's make that. Tried to clean it up and I messed it up. So it's a negative 5 in there. So we have negative 40 plus 5y equals negative 55. And so I'm going to add 40. And I get 5y equals negative 15. We'll divide by 5, and y is equal to negative 3. That gives us my x value and my y value. Correct format and correct answer. Oh, and I didn't do the yellow one here, or else it went away. Okay, so we have 3 examples here of elimination. The second one, we have to change the problem. If that 2y here had been a positive, I would have had to make one of them negative, or would have had to subtract. Both of those are good ways to do it. Okay. So now that's substitution at the bottom of the first page, and then elimination on the second page. Thank you for watching. I hope this was helpful.